Still on section 5.1.1, example 2. We're going to simplify this one. So this is x to the fifth plus x to the negative second divided by x to the negative third. This is where order of operations really needs to be followed. You can't just take the x to the negative second and drop it into the denominator because the exponent is negative. That has everything to do with the addition sign up there. So you got to be careful. But what you can do is you can decompose this big fraction right here into the sum of two fractions where the denominator is x to the negative third. And that is because there's only one factor down there in the denominator, x to the negative third, or one term for that matter. So I'm going to decompose it into a left fraction plus a right fraction. So it's x to the fifth over x to the negative third plus x to the negative second divided by x to the negative third. And then I'm going to simplify individual fractions from this point forward. So in the left fraction, x to the fifth divided by x to the negative third, I subtract the exponents. I end up with x to the eighth. On the right fraction, -2 minus a -3 ends up becoming a +1. So now I have x to the first. And finalizing this, it becomes x to the eighth plus x to the first. It's not what you would expect it to be. You can't just take this -2 and drop it into the denominator. It causes some problems there. Now, this is one way to approach it. Here's another, right? So that x to the negative third right here, again, instead of decomposing this into two fractions with the same denominator, you can kind of rewrite that denominator of x to the negative third as a 1 divided by x to the negative third, right? That's kind of this right here, okay? We've dealt with that with trig identities often, and then it's going to be times x to the fifth plus x to the negative second. In this case, now you can take this group and you can address that negative exponent and make it x to the positive third, right? And now we distribute. And if we distribute from here, we end up with the same exact answer. And you might like this way a little bit better. But when you distribute, you end up with x to the third times x to the fifth, giving you x to the eighth, and then x to the third times x to the negative second. When you add those exponents, you get x to the first, which you don't have to express as x to the first. You can just write x to the eighth plus x, and then you're done. Here's one for you to try. Again, this has two terms inside the big group. There's an addition, so that causes some trouble. That means you cannot distribute. This is not okay. You can't do this. It's not going to work. That has everything to do with there's two terms in this group, so don't attempt to do that. It's just going to turn into a disaster at that point. So let's see what happens, right? The negative exponent out here, right? I'm going to express it in red right now. This x to the negative first, you can rewrite this entire group as 1 divided by a to the negative second plus b to the negative second to the positive 1 now. That's legitimate. And when you do this, the negative exponents in the group do not become positive. It's only that initial exponent here that becomes positive now. And then at this point, there's some strategies which you've learned how to deal with in the last chapter, right? So you might not understand how it works yet, and I'll try to talk about that. But if you think of this a to the negative second right there, that's a fraction. It's 1 divided by a to the second. And the b to the negative second is also 1 divided by b to the negative second. Or positive second, excuse me. So you can use the least common denominator of those two denominators and multiply this big fraction, right? The numerator of the fraction, and then the big denominator of the fraction by the least common multiple of the little denominators that exist, a squared, b squared. So when I multiply a squared, b squared to 1, it becomes a squared, b squared. And when I distribute a squared, b squared to the group in the denominator, well, a squared, b squared times a to the negative second. When you deal with the mathematics there, negative a to the negative second times a to the second produces, if you think about the math, it's a to the negative second plus 2, which is a to the 0. A to the 0 is 1. So you're really only left with that b squared right there. And then distribute again. A squared, b squared times b to the negative second, right? The same concept is going to apply, but with the variable b, or the base b there. So you'll end up with b to the 0, which is 1, but you'll have an a squared left. Now, this is where we're at. Now, this is considered fully simplified. All the exponents are positive. And some of you might say, hey, wait, we have a's. You know, you have an a in the numerator and the a in the denominator. Can I cross those out, especially because they're both the same exponent? Absolutely not. That addition sign right here prevents you from doing that, first of all. Some people also might say, I thought you're not allowed to have the same variable or base existing in the numerator and denominator. In single monomial expressions, that is a true statement in most cases. And the simplifying will evolve over time. And, you know, some of those rules will, you know, become more rigorous. But for now, this is completely acceptable. That addition sign, you know, prevents you from simplifying this any further. And that's as far as we can take it.